Hey guys, welcome back. Let's continue on with the coding of our objects for our Space Invaders. So we've covered platform, instructions, hero, game over, as well as all the bad guys. So let's move on to the just last four objects that we have with the bullets and the explosion and the game controller. So let's start with bullet. So object bullet bad. So this is the bullet that the bad guys are going to be shooting at you. For variable definitions, we have one definition or one variable, which is our V speed, which stands for vertical speed in GameMaker. It's what tells you how fast to move up and down. I'm going to set its value to 5. I thought that was like a decently fast value for the bullet. You can change it to whatever else you'd like. Remember, positive numbers make something go downwards in GameMaker, and negative values makes things go up if you're talking about vertical speed. To add this, you go variable definitions, add, and then there you go. For events, this bullet is going to have 3 events. Let's start with the easiest one, outside room. So to do that, you go add event, other, outside room. So when the bullet leaves the room, what does it have to do? It has to destroy itself. So that's all we're doing, instance underscore destroy. So once again, when a bullet flies and it flies outside of the room, so that's the little playing area, it shouldn't keep existing and flying down, south as far as forever. So we want to destroy it. Let's talk about when it hits a platform. So when the bullet hits one of these platforms that once again we're using to create these shields above the player, what it needs to do is it needs to destroy the platform. So to do that, you go instance underscore destroy, and then you pass in the reference to other. Other is the other object that it just hit. So in this case, it's the platform object that you just hit. So you destroy that object, and you also destroy the bullet itself. So when you hit the platform, both of these get destroyed. And the last one is object collision with the hero. So when the bullet hits the hero, we need to do a few things. So first, we need to decrease lives. That's kind of a given. Then we need to set the image speed of the hero to be 1. This is the thing that the controlling mechanism that we're using throughout the game in a bunch of different objects. So we go other. So other in this case is the hero. And then dot image speed equals 0. So that means we've effectively turned on the animation, the blinking animation of the hero. And that should in turn shut off everything else. And then we also set an alarm in the hero. So we go other.alarm 0, 120. So 120 is 2 seconds. I'm saying you're going to stay dead for about 2 seconds. Yeah, so that's how we use the alarm. And if you remember back in the hero, we have an alarm 0 where image speed is set to 0. That's where you go back to I think there's actually a glitch in here. Okay. Sorry, this is something I totally missed. So in the object hero, in the alarm 0 event, we need to make sure we set our image speed to 0 so there's no more animation, but we also want to set our image index to 0, because if we're currently on the second image, which is the blank image of our hero, and we set the image speed to 0, you might be stuck with a blank hero and you won't be able to see the hero anymore. So we have to set the image speed to 0, but then we also have to make sure that the current image in the sprite is the first one, which is the one that has the hero actually drawn. So that's just some code in the hero. Let's go back to the bullet bad. Yeah, so we set the alarm, and then we play the ouch sound. So audio play sound, sound ouch, same thing. Playing the sound is always the same in small games, unless you want some kind of spatial sound, but we're not going to talk about that in this lesson. And then we have to do, so this is the part where the player was just hit, so we need to do some checks to see if should we keep playing or should this be game over. And the way you do that is you check to see if lives is equal to 0. So if lives is equal to 0, then that means you've run out of lives, game over. And then we use this curly brackets and we do the same thing again. So we're going to check to see if your score is bigger than the high score. If it's bigger, then we set it to high score, we save the score, so on. It's the same as we did in the bad guys when they hit the platform. And then we go to next room, which is the game over. Okay. And then finally close the brackets and then instance destroy. We're destroying the bad bullet. Yes, so that's all the code for the bullet. Now I do want you guys to make an observation here. This code here is, I believe it's the exact same code as this code here. Yeah, you can actually see if I put them side by side. This code and this code is the exact same code. So we need to figure out a way to fix this. This is repeating ourselves. We're typing the same code twice. It's very bad coding practice, because what if I want to change something? I need to go and change it in every single location. So we're going to create our first script. So go over to the script section here, right click, click create, and then click script. And we're going to call this script game over. Let's just go game over, just like that. So game underscore over, that's the name of our script. I'm going to go back to here. I'm going to take all of this that's in my, I can take either one. So I can either take the code from here or from here. It's the same code. So I'm going to highlight all of this, Control X to cut it. So that's removing the code from here. And I'm going to throw it into this script. Just like that. So we can delete the stuff above. So I've created a script which holds all the same functions that we had in the other objects before. And now instead of having to type out all of this every time I need it, I can simply close the script, go up here, and here I can just type game underscore over. And now the same thing that was here before is running inside the script, and I can call it here simply. So up here too, if my lives are equal to 0, I can take all of this, I can press backspace to delete it, and I can simply call the same function again, game over. Okay, and now because it's a one-liner, I don't even need the brackets. And this way, if I need to change anything about how the game over event happens, I can go into the game over script. I only need to change it in this one location, and everywhere else where it needs to be used, it automatically gets updated properly. Good, so that takes care of our bad guy bullet, or bullet bad, I mean. Let's move on to bullet good. Okay, so bullet good. Let's start with outside room. So it'll be very similar to bullet bad. So when you're outside the room, you destroy the instance. When you have a collision with the platform, so collision events, just if you've forgotten how to add them, you go add event, collision, objects, and then find the object that you want to have a collision with. So when there's a collision between the bullet good and the platform, we destroy the platform and we destroy the bullet. So same as before. And then it's almost like I could have created a bullet parent and put these two events into the bullet parent because they have the same event. I just didn't find it necessary in this case because there's only 2 of them. If you had a lot of them and there's a lot of code in them, then I would consider like if you had power-ups, let's say, and you create like all these different types of bullets that have different effects, but these 2 effects would stay the same, then I would consider creating a parent bullet. And then when you collide with the bad guy parent, what we need to do is destroy the bad guy, destroy the bullet. We need to create an explosion where they hit. So, or sorry, not where they hit, but where the bad guy was. So I'm gonna go instance create depth other.x. So I'm taking the x position and the y position of the other object, in which case it's the bad guy that I just hit. Depth can be the depth of the bullet, that's irrelevant in this case. And then I'm going to create an object explosion. Okay, so that just replaces the bad guy with an explosion in its place. I'm going to set my score. Plus equals means I'm taking my score and adding something to it. The something is other.points. So remember that points variable that we set in the bad guys? Well, now we're using it to increase our score. And then the last thing I do is when this whole thing happened, I'm going to see if there's no more bad guys in the room. So if you call the function instance exists, bad guy parent, that is going to check for every single type of bad guy. And by putting the exclamation mark in front, I'm saying if there's no more instances of bad guys or objects of bad guys in my game, then I'm going to restart the room. And this is the difference between restarting a room and restarting the game. You remember that the game over object completely restarts the game, whereas this time I'm only restarting room. So I'm not resetting my score, I'm not doing anything like that. I'm just restarting the room, setting the enemies back at the top, and then I can continue playing. I'm also not resetting my lives. You'll see this in more detail when I get into the object game controller. Okay, so that's the bullet. Good. Explosion is fairly simple. It has a variable, alarm 0. So I'm just setting the alarm 0 to half a second. 30 steps is half a second. I can change this to integer. So I want it to be alive for half a second. In the create event, when these explosions get created, I play the explosion sound. So that's sound play explosion, or audio play sound. Sound explosion, 100 and false. And then alarm 0, when that fires, I destroy the explosion. Okay. So instance destroy. That's it. So there's one more object. This one's the scary one. This is the big one, the game controller. So let's see how it works. Variable definitions. I've got a few variables in here. I've got a counter. So the counter is the variable that keeps track of when it's time to move all the bad guys over. Move speed. So move speed is how much do I move all the bad guys over? How many pixels, right? So if you want them to move in very small steps, you can make this a small number. If you want them to jump bigger, then you can make this into a bigger number. Drop. So drop is the variable that tells the game controller how much they need to be dropping downwards. When they get to the edge of the screen, they need to drop down. By default, it's set to 0, but you'll see some code later on. We'll set it to the move speed, and whenever this variable is not 0, then we perform the drop. And then step time is, I actually wanted to show you guys a different way of doing this, so this might be a little bit confusing. Let me just fix this. I'm gonna actually remove this. So step time, let's do step time in number of steps. So if I want 1 second, I'm gonna have 60 steps. Okay, so these are my 4 variables. Step time could also be an integer now. Okay, so we have counter, move speed, drop, and step time. And then let's start with the actual code. So let's start with the easier ones. So I'm gonna go add event and other game start. So game start only happens when the game starts. It doesn't happen when a room gets rebuilt, or room restart does not call the game start event. Game start event only happens when you go game restart, or when you initially click the executable to start the game. So in the game start event, we need to read in the current score from the save game file. So to do that, we open the file, ini open, and then the file name. We set our global.highscore to be the value that's being stored in score and score. That's just the, once again, section and the key. And then default, if this value does not exist, or it hasn't been set yet, so maybe the very first time you play the game, then it loads 0 into our global high score. And then we close the reading of that file. We set our lives to 3. So this is something that you could change here. Actually, the best way to change this would be to create another variable here. And I can do, I could do something like starting lives. Set it to 3, integer, and then over here I could type starting lives. The reason for doing it this way is so that you can edit the number of lives you want in the level itself, so you don't have to come back to this object and change the code. You can simply go into the room editor, I'll show you that later, and change the starting lives to something else. And you might be wondering, why didn't I just type lives equals 3 in here? Well, it's because when you do a room restart, this object gets recreated. And when it gets recreated, it would reset your lives to 3. But that's not what I want. I want it to be so that every time the room gets rebuilt, because you just beat the room, you have to continue on with whatever number of lives you had left before. So that's why I'm only setting my lives in the game start event and not the create event, or this is called the pre-create event, so it happens right before creation. Good, so that's lives. Score, same thing. I don't want to reset my score when the room starts. I only want to reset it when the game starts. And then finally, we start playing the music. So audio, play sound, sound, music. And once again, I only play this when the game starts, not when the room starts, because if I play this when the room starts, then the sound would keep playing over top of each other, and you'd have several music playing at the same time. Okay, so that's the game start event. The draw event, I use the game controller to draw like my GUI at the very top. So I just set the font to be FGUI. I set the alignment to be left align first, so that's for the left section of the screen. And it's going to say X, Y, and score. And then I'm going to print my score. So on the left-hand side of my screen, I'm printing my score. Then notice that for the second section, I set my horizontal align to be center align. So now the words are going to build both ways from the location that I typed below. In this case, I'm going the X coordinate, so that's the horizontal coordinate, will be room width divided by 2. So that's going to be in the very middle of the room. So I'm going to start typing in the very middle of the room. Y will be the same Y where I place this object vertically. And this time I'm going to print high score, and then I'm going to take the value of high score, once again convert it to a string, and then go from there. And then finally, for the last part, I move on to the right hand side of the screen. I set my horizontal alignment to be right aligned, so everything is typed to the left now. And I'm going to take the room width, so that's the far right side of the room, minus the X position of the object. So this is kind of cool if you think about this. On the left hand side, my object is some pixels in from 0, and that's my X location. On the right hand side, I take the room width and subtract the same number of X from it. So in terms of like the distance from the edge of the screen, this will create the same distance on both ends of the screen. Vertically, I place it in the same location, and then I say my lives equals to whatever number of lives I have left, using the string and then lives variable. Okay, so that's that. Now the hard part. This is the step event. So this one took a little while to figure out how to make it work perfectly. And so step event. First, let me show you how to add the step event. So you go add event, step, and step. So the step event happens every single frame of the game. So this is happening 60 times a second. You have to keep that in mind. And that's why we have things like counters. So we don't allow it to happen every single, or the contents of it, we don't want it to run every single frame. But anyways, at the very top of this, remember I said if there's an explosion, or if my hero is blinking, as in he's dying, then I don't want the bad guys to move or shoot or anything like that. So you can achieve that by doing something like if instance exists. So we're going to check for an explosion, or we're going to check to see if the hero's image speed is 1. So if either of these scenarios are true, then I exit. When you call exit in a function or in an event, it skips everything that comes after exit. So it just exits the function. So this prevents any of this from happening while my hero is frozen, or if there's an explosion. Next, we start going down. So now we check that counter, so a counter variable that holds a number. And if that counter variable has reached a value of less than 0, then we reset it to the step time. So this is where we put 60 before. So 60 is every 1 second. And then this is a new coding feature as well that you guys probably have not seen before. When you type the word with and then type in an object name, so this is not an instance, this is an object, that means that every single object that has a relation to this, so in this time it's the bad guy parent, so bad guy 1, bad guy 2, and bad guy 3. So every instance of those objects in the room is going to be running this code. So instead of having these objects run their own code, I'm now using the game controller to run some specific code in them, but at the exact same time. It's very important that you do this. Sometimes it's very important that you run the same code in all the objects at the exact same time, because that way you know the flow of the code. So here, the code we're going to be running, you need the brackets, of course, is we're going to check the X position. So now this X position is not referring to the X position of the game controller. Now it's referring to the X position of the current object that it's running the code on. So we're checking the horizontal position to see if it's less than 16. And if other.moveSpeed, so this time other.moveSpeed is talking about the controller's move speed, if it's negative. So if the move speed is negative, that means things are moving to the left. But if one of these bad guys is already all the way to the edge of the screen, which x is less than 16 is saying to me, if they're all the way to the edge of the screen, but yet the move speed of the parent is still negative, that means in the next step or next counter, it would move left again, which would mean it would move off the screen. So we want to prevent that. So what we do is we set other.moveSpeed, so that's the parent's move speed. We set it to be the positive value. So absolute, this is absolute value, this is a math function of other.moveSpeed. So regardless of what the sign, so whether this is positive or negative is, we're going to set it to be the positive version of it. That's what absolute value does. And then we're also going to say that other.drop, so this is where the drop value comes into play, is also going to be the positive value of move speed. So it's in this case 8, so drop becomes positive 8. Or sorry, in this case this would be negative 8, but it turns into positive 8 because of absolute, and then drop also turns into positive 8. And so if this is not true, if none of the objects are touching the left side of the screen, then we're going to check to see if they're touching the right hand side. So this is the same thing. So if their x is greater than, room width minus 16, so same 16 pixels away from the edge of the screen, and this time we're checking to see if the move speed is positive. So if they're at the edge of the screen, but they're still supposed to move more to the edge of the screen, then we change the move speed to the negative absolute value. So now we're going to take the positive value of move speed again, but put a negative in front, so now it's the negative value. And we're going to set the drop once again to be positive. You're always dropping downwards, which means you're always dropping in the positive direction. And we close this. So this part of the code here will tell us if we need to, is it time to drop? Is it time to drop? Is it time to change direction of steps? Once we've determined if any of these are true, it might be that none of these are true, in which case nothing happens. Everything just keeps on going as is. But if, regardless of what the result of this is, every single time there's a counter step happening, we need to change the image index of each bad guy. So we go 0, 1, 2, 3, 4. But when you go past the maximum number of images in a sprite, it just goes back to the beginning. So that's why image index plus actually works fine in this case. Yeah, we're just swapping between two images every time you take a step. That's why it creates that blinking effect. And then we go if there is a drop. So if the game controller has a drop value that's not equal to 0, which it wouldn't be if either of these became true or set, then we move the Y location of each of these bad guys down by this drop value. If drop is if it is 0, then it would skip this, and instead we would take the X position, horizontal position of each one of these guys, and shift it by the move speed that's stored in the game controller. Okay, so that's how you move the guys. So here you determine which way they need to move. Here you actually apply the movement to each one, and then we play the audio's play sound step, which is the once every step you play a sound. It's just like it's a cool indication. It's feedback to the player that bad guys are moving, and so on. And if as an extra challenge for you guys, if you decide to over time decrease the step time, so they start stepping faster and faster and faster, then this sound effect would also play sooner and sooner and sooner, which would make the game more intense for the player. And of course, regardless of whether there was a drop or not, we want to set drop to 0 at the end of this, because if there was a drop, we would have dropped all the bad guys already. Okay, and then the last part, regardless of whether we did do a step event or not, we need to decrease the counter by 1 so that we get closer to being able to run another one of these. Okay, so that is the code in the game controller. It's a lot of code, it's a lot of logic, but this is where the games get more complicated. Some of the logic and the features of the game gets more complicated, and it takes a while to work this out. Like, you really have to think through, like, how can I achieve what I'm trying to achieve? But to me, this is the most exciting part of coding, where you get to really problem solve your way through and figure out a way to make it work. And this is just one of many solutions. Like, there's probably so many different ways you could have achieved this. This is the way I chose to achieve it. Okay, so that's it for the game controller. And I believe that's it for all the objects. So in the next video, I'll show you guys how to build the rooms, and that should be the last video, as it will be showing you what the final game is like. Thanks for watching.